In the previous chapter, we viewed the basic soldering tools. Let's solder an axial resistor. A tin tip contacts the lead and pad. Touch the solder to the tip. Push the solder down the hole before the flux evaporates. Continue heating for 3 seconds and remove the tip. Once the excess lead length is cut, the finished joint is smooth and concave, similar to an inactive volcano. Now bear with me, this model has helped many students. Let's pretend that this solder sucker is a hot soldering iron. Let's pretend that the spool top is the solder pad on the board. Let's pretend that the forceps represent the component lead and in my left hand is the solder. We want the tip to make a good thermal contact with the lead and the pad. If I touch the tip only to the pad, will the lead get hot? If I touch the tip only to the lead, will the pad get hot? So we want to find a tip position which heats both effectively. Sometimes we can place it behind the lead. Sometimes we place it away from us. If I cover the hole, will the solder flow to the other side of the board? No, the solder will blob on top of the tip. Once we find a comfortable, effective tip position, start melting the solder on the tip. The tip is the only part hot enough to melt the solder. Once we have a pool of solder at the junction of the tip, lead, and pad, we want to push the melting solder down the hole before the flux evaporates. When the solder forms a volcano on the tip side, remove the solder wire. But we still have fresh flux to help us make a better solder joint. So we keep the tip on for an additional 3 seconds and finally remove the tip. Let's look at this process in a continuous motion. Good thermal contact. Start the solder on the tip, down the hole, volcano, 1, 2, 3, and off. Remember to wet the sponge. See that it takes about 3 seconds for the flux to evaporate into the HEPA filter. Remember, if you feed the solder into the tip, it will only blob on top of the tip. Hot solder has the consistency of peanut butter. Adding fresh flux from the solder wire makes it flow again. Solder melts instantly on a properly tinned tip, but it doesn't melt on the chrome-plated part of the tip. Immediately before soldering, clean the tip on the wet sponge. Notice how quickly the solder melts on the tip. The top tip is properly tinned. The bottom tip has oxidized. Notice how difficult it is to get the solder to melt on an oxidized tip. It takes several applications of fresh solder to get it properly tinned. A dry sponge does not clean the tip very well. The sharp tip digs holes into a dry sponge. By the time we have thoroughly wiped the tip, it is oxidized. Let's review. Good thermal contact. Start the solder on the tip. Down the hole. Volcano. 3 seconds and off. The left solder joint made a good volcano on both sides. The right solder joint did not flow down the hole to make a good volcano, so let's fix it. We add a little solder. Heat for 3 seconds and off. These are very sharp flush cutters. This cutter can cut off the entire volcano flush with the board. But we want to lift the cutter, cut only the excess lead, and leave the entire volcano. Remember our volcano? NASA prefers a good volcano on both sides. So for basic soldering, we wet the sponge, tin the tip, keep the tip tinned, clean the tip immediately before we solder, position tip for good heat conduction between tip, lead, and pad. Start the solder on the tip. Gently push the melting solder down the hole. Remove the solder when you have a volcano shape. Continue heating for 3 seconds and remove the tip, like this. After soldering, put the pencil into the stand. We have a volcano on the solder side and a volcano on the component side. Well done! Good volcano on both sides.